Hello, this is John Courier again, your 50-year-old equipment guru for the spray foam pro component equipment in foam and coatings. And today I'm going to talk about 50-year-old preheaters. Um, and this is another series that I wanted to put out. These preheaters used to be just pipes with these same old fire rod steel springs inside of them. Now in a compact square aluminum case, but not a lot of thermal mass to them. And I don't know why they did that. And then the springs are still typically 18 inches long and have only a BTU of 27. That's for the steel, because of the steel springs. Where aluminum is a wall factor of 136 BTUs to transfer heat into the fluids. Each steel spring loses over 100 psi pressure in each preheater pass. Typically times 4 equals 400 psi loss in pressure because just the springs. I have done several test videos. Now, then the next thing I want to show you here, if you look at the pictures, if you look at this upper one here, you can see my mouse doesn't show up very big. It shows up big on my screen, but it doesn't show up much on the video. But the old Graco one up at the top right hand corner shows the thermocouple wire coming down in between the springs. And those springs are so tight, you almost have a full stop block off on flow coefficient there where that happens. That is not needed nowadays, and I'll show you why as we go forward. The same thing for the PMC one down below it. Those are the two old style preheaters. If you look down below what I've just stopped, that's an aluminum spiral. And that spiral is, hey, 1 second. Okay, that spiral is about 3/8 of an inch wide, if you could see it here, and it's treated aluminum and softened, and has about an inch space between it, so you got plenty of room to put any probe or fire rod in there and not cause a flow restriction. And when I've done the testing with these, I have no flow pressure loss whatsoever. Okay, so this is what you're looking at there is a heavy-duty aluminum spiral over the fire rods. Notice the large spacing and no PSI loss. Okay, and now let's go down, going down here a little more. There, the high aluminum spot. This is the same for each side, ISO and resin, 400 pounds pressure loss in each component side. Now, if you can see with the blue arrow there, it gives you a real nice bit of space and so forth. The fire rod should not be in the component fluids, as they can burn and contaminate the chemicals. Example, when the old fire rod just as the thermocouple pressed against the outside of the fire rod, and with a loose spring that cannot hold it stable in the fire rod compartment. It warps, and your books will all talk and refer to it. You lose contact, excuse me, and within seconds, that fire rod goes up to 1,000 degrees Fahrenheit, burning the chemicals. If you must, excuse me, if you must use a fire rod in your products, at least use the aluminum spiral pictured above and the long spiral. With this in the 1/2 inch fire rod in it, has a 7/8 gap between the flutes and will hold the fire rod stable and not move when it heats up. This aluminum spiral now has no pressure loss, giving you 400 more psi of pressure and also a transmission rate of 136 BTUs per minute. Heat transfer should have been fixed 50 years ago. Graco, PMC, they're all still using all this same old technology, and it does not need to be used, and they're using such high amp fire rods. I'll get into that a little more as we go forward. The fire rods for the first past 40 years I know of has the thermocouple wires come out of the fire rod, controlling the heat from inside, not allowing it to spike or overheat. See below on the next page, this is an old, not recommended method. Look in any manual by the manufacturer and you will see where they attempt to address this problem. For all of the above reasons, it has been proven and advised not to have fire rods in the controlling fluids. Okay, and the thermal conductivity aluminum 8. This makes aluminum the best material for transferring heat into liquids. All preheaters in the market currently use steel springs over fire rods, the poorest method to transmit heat into resins. Thick aluminum springs and aluminum cylinders for thermolast greatly improve performance. Each steel spring can cause 100 pounds pressure loss, I told you before. Present proportioners are not insulated and lose heat from the preheaters to the heated hoses. Aluminum manifolds mounted on a cold aluminum chassis lose 25% of the heat in this section. Okay, let me come up here a little more. And this is going to start giving you an idea what we're coming into here. Massive preheaters draw huge amperage with no insulation to their tubes that control the flow of the products from the drum to the proportioner. Once the fluids leave the preheaters in small metal lines with no insulation, the fluids cool or heat back to the ambient temperature quickly. So, you got 15,000 watt preheaters and a 40 kVA generator that costs a lot per day to fuel, not efficient in our systems. We heat our 500-pound drums with a little 500-watt blankets that only draw 4.6 amps on 120 volts. This is useless with uninsulated supply hoses. We need to control the temperature of both fluids from the drum to the gun with less amperage draw than we are using presently. See SPFA Tech Tip G10 will show you about a 10-page manual how to fix and re-insulate and make your system much more controllable on ratio because you're controlling the heat for the coefficient of friction and flow. Heat tracing your supply line from the drum to the proportioner alone will control the beginning heat to the system. We need to gradually heat the materials and control temperatures all the way from the drums to the gun. Okay, you can see there, basically it comes out of that machine set there at 135 degrees. Jeff's machine here in Washington, 46-degree day. It dropped from 135 out an uninsulated steel line into an aluminum chassis, manifolds mounted on aluminum chassis, and it went from 135 degrees down to 85 degrees before it went into 300 feet of spray hose. Went 300 feet, and Jeff was spraying, doing in low commercial housing projects, spraying the foam, and on a 46-degree day, the foam was running down off the walls. Okay, so let's go forward to here a little more. Whoops. Installing a 400-watt heater at 4.16 amps at the foot valve of the B resin pump to change the flow ratio in a system. Just that much. The B resin is sensitive to heat and cold and affects spray ratios. Now, the unheated resin hose in winter will lose all of your heat long before it gets to the meter, if not spraying constantly. Summer heat could cause frothing and unable to pump. Proper insulation of supply hoses from the drums to the pusher is vital to maintaining proper temperatures through the system. Strategically placed low wattage heaters can reduce the size of your generator, fuel consumption, and maintenance costs, and still give ample heat to your spray gun. If you feel heat from the hose outside in the winter laying on the ground, you're lacking insulation on your spray hose. Too many amps are being used to heat our present-day systems with the demand huge generators with higher operating costs. Okay, fire rods that heat the chemicals directly can cause damage to the chemicals as well as destroying the outside jackets of the fire rods. They cause 100 pounds pressure loss in every 18 inches of the springs. Okay, let's go on down here. And I want you to see a little bit there about that preheater there. That I'll try to explain this one and what's a little difference in it. That's heater that you're looking at here, over here on the side. The back side is the A side, the front side is the B side, and there's two 3/4 inch fire rods that are in the middle. Let me look here. See if you do the two black rods, those are in the middle between. They're not in the products, they're just heating the aluminum. And to the right is the preheater that has two 3/4 diameter fire rods to heat the thermal mass aluminum with 3 passive tubes with helix ribbon twists. Several options for this best temperature control encased with 3 different installations. All installation contractors need to do the job right. Insulate your equipment. Okay, let's go down here. This is a fire rod with both 230 volt and 3 thermocouple wires on the inside of it. You see here? Now if you look up here right to your left over here, the first 2 over here on the right are the power lines, and inside this are the thermocouple wires. So what this does, this thermocouple and this fire rod now can be minutely controlled to temperature quickly, not depending on some probe on the outside of it, where if it springs away and there's a gap there, it'll raise it 1,000 degrees in seconds and burn your chemical. This is more of a modern, popular way for the last 40 plus years. So it's ridiculous that our technology and our equipment people now, to this day and age, are using that old technology with the probes and springs. It's an antiquated technology. It needs improvement. I'm John Currier. I'm 50 years in the equipment business at the spray foam and coatings and Polyurea technologies, and my website is ectech.com, or my email is 2johnpc@comcast.net. I thank you for attending and watching this, and please comment or sign up for my systems. Thank you.